This chapter, we are studying infinite series. So we're going to take a list of numbers that going all the way to infinity, adding up a list of numbers all the way to infinity. And sometimes we're able to figure out that hey, that list narrows down enough to where we say that actually has a sum, even though we're adding up infinite numbers, that thing will have a sum, and we say that converges. And then sometimes it just goes out to infinity, and we can't get a sum for that, and the sum doesn't exist, and we say that diverges. So the majority of this chapter, we're going to learn just in this video is just the geometric series test, but there's going to be a total of 10 different tests that we learn whether to decide whether something is converge or diverge, whether infinite series converges or diverges, because not everything is going to be a geometric series. So each little test, I think, is pretty straightforward and actually going to be, you're going to like this chapter, I feel. The challenge becomes when we put all 10 together, when we mix everything up, trying to decide which test that we're going to use here. So as you're going through the homework there, you will get some experience with these, and you'll know on a lot of them, like, oh yeah, I know this is going to be this test. I know this is going to be this test. And then some of them you might not know, or might be a little bit trickier. And so we'll get you experience with all the different things there. And when we learn all the different 10 tests, then at the end, we'll summarize everything and we'll talk about how I know when to do this and when to do that. But a lot of that's going to be done by doing your own homework, right? Also, these things are kind of like little mini proofs in this section. So there's not really a lot that you got to write down for most of the problems there, but whatever we have write down, just kind of model what I show you in the notes there. If I have a limit of something, then make sure you write that down. And a lot of times, sometimes people want to be lazy with that notation and get deductions on stuff like that. So we want to make sure we're developing good habits for the AP test, good habits for being thorough with our college preparation. And so make sure we write stuff down or not being lazy with the notation. All right. Something real easy to start off with there is something called a geometric test, right? Geometric series, you worked with these last year in pre-cal. That's when you're multiplying by the same number each and every time, right? So both of these series are geometric series. If you're not sure, look what you could always do. I'm talking on even like a trickier one in the future. If you're ever not sure what's going on, what you could always rely on is simply like plugging in the numbers, right? Like if I plug in 0, a number raised to 0 pi, that's going to give us 1. And if I plug in 1, we're going to get 4/3. And if I plug in 2 for that n, we're going to get what? 16/9. And then a 64 over 27. And then that list just keeps on going on to infinity. That's an infinite series, right? And you can tell it's a geometric series because you're multiplying by 4/3 each time. So that's what our R value is. Our R value is 4/3. It is a geometric series because you're multiplying by 4/3 each time. And then here's what we're going to know. Here's what the geometric series test tells us. If that R value is in between -1 and a +1, then we're going to say that series converges. If it's bigger than 1 or less than or equal to -1, then we're going to say that it diverges right there. So for this whole entire chapter, most of the time what we're going to do, we're going to ask you to determine whether a series converges or diverges. So we're going to write converge or diverge down. We might have a little bit of work to do on some of the problems, and you're always going to tell me what test you're being used, okay? So right now, this is the only test that we're learning here. All right, so basically, I got my R equals 4/3. And then, so I'm just going to have this memorized. Since that's bigger than 1, I know this is going to diverge. So when I ask you, does this series converge or diverge, you're going to write diverge down, and you're always going to tell me what test you're using here. We're using the geometric series test. All right, so always tell me converge or diverge and tell me the test that you're using. And then depending on what the test is, the only work we need is just to make sure we write down what that R value is. You can kind of write this down if you need to, but typically when we get more experience with these, when you see a number raised to the end like that, if you don't have any extra variables out there, that's going to be like a geometric series. So converge or diverge, geometric series, and that's the only work that we need to have for that. Different tests that will have converge or diverge will have a different name for a different test, but then we might have different work, and you just model that from the notes there. All right, so just looking at this infinite series then, when you see that number raised to the end and you got that extra number there, like if I have an extra n out there, that's not going to be a geometric series. But if you have nothing but numbers right there, that's going to be a geometric series where that R value is at -1/2, right? So I jot that down, and I know since that R is in between -1 and a +1, that tells me that this infinite series is going to converge. So you're going to write converge down, and then the test that we're using here is the geometric series test. All right, so as long as you have convert or diverge, tell me the test you're using, and then that right there. Now, if I'm talking, if these are like 10-point problems in the future, if you just write convert or diverge down, and you don't tell me the test you're using, you don't have what the R value is, you're not getting, you might only get like 1 out of the 10 points for that. I'm not gonna lie, just to get lucky, you got a 50-50 chance of just getting that right if you just guess, right? I'm not allowing you to just get lucky and get a bunch of points just by guessing right there. You gotta always have the proper justification down. And then we'll be good there. Now, if you're not sure if it's geometric, you could take the 1 and plug it in, take the 2 and plug it in, and you're going to get like -1 plus 1/2 minus 1/4 plus 1/8, dot, dot, dot. Like those are the numbers that you're going to get when you plug in those numbers, starting with 1 and going all the way up to infinity right there, right? And then notice how you're multiplying by -1/2 each time. That's why that's your R value, that's your common ratio. Now, it might seem odd to you that we're adding up a list of numbers all the way to infinity, but we're able to get a sum for that. So the converge means that's going to narrow down enough where there is a sum that exists, and we can actually get a sum for that. Diverge means those are just going to keep getting bigger and bigger, and it's not going to narrow down for us, and it's just going to keep going out to infinity. We're not going to be able to get a sum for that. So you already kind of know this idea, like a horizontal asymptote. Sometimes a graph will get closer and closer to that, right? And approaches that number there. And so that's what we're going to do here. It's going to approach some sum. And I always use the example of like a cake, right? If somebody can make like a real delicious chocolate cake, right? And they bring that into class. And basically I'm going to take that cake and I'm going to cut that in half, right? And then I'm going to pass it to the next person, right? And then they're going to take half of that half, and then they're going to pass it to the next person, and they're going to do half of the half of the half. And then it's going to get all the way around to the last person in the class. And if they're smart, maybe they can bust out a microscope, bust out these microscopic like little knives and tools and stuff. And what might be left on the plate is just a little crumb of that chocolate cake. Those crumbs are pretty good too. When you're eating a chocolate cake, you got to get those crumbs off the plate there at the end. That's always tastes pretty good. But theoretically, then, if you have the tool small enough, you could cut that crumb in half, and you could cut that crumb in half. So the point is, like, when you add up half of the crumb plus the other half of the piece of the cake and half of the half, when you add up all those halves that we've been taking out of that cake, when you add that all up together, it equals that one whole chocolate cake right there. But notice when I said I'm taking half of that cake, my R value is 1/2. That was in between the 1 and the -1 right there. That's going to converge. I didn't say I'm going to take the cake and I'm going to take like 4/3 of that. That wouldn't make any sense. That's going to diverge. So that's what we mean by sometimes we're able to get a sum for that and equals that whole cake, and then sometimes you're not able to get a sum for that. Now, if it's a geometric series, we won't, in this chapter, most of the time, we just want to determine whether it converges or diverges. But there are a couple different tests out there where if it does converge, and if it is geometric and it does converge, we can actually find the sum. You work with this formula, you proved this formula last year. So this is the infinite sum formula for a geometric series. Or if it only works with a geometric series, if you have an infinite geometric series, that sum is a over 1 minus r, where a is the first term and the r is what you're multiplying each time by. So if we go back up to this one, I say, okay, since this is a convergent geometric series, I can actually find the sum now. So I know my a is the first term, which is that -1. And then my R value we said was the -1/2. And so if I want to find the sum, so if I add up all those numbers all the way to infinity, what would that sum be? I just use this formula as a over 1 minus r. So I'll go -1 over 1 minus -1/2. Minus negative is plus a positive. And then so that's going to give us -1 over 3 over 2. And then 1 over a fraction is just the reciprocal of that fraction. That negative is right there. And then if you didn't believe me, like if you wanted to, you could just kind of write down like the first 50 of those terms or so, add those all up in the calculator, and your answer is going to be really, really close to that -2/3 answer right there. So there's your geometric series. So for the whole chapter, model the notes, whatever work that I have down there, and then we're going to put converge or diverge, and then tell me the test that you're using. And then we'll get experience individually with each section. We'll master each section, and then when we put them all together, a lot of that we'll just have to make sure we study what that problem looks like and recognize when to use which test. And I'll summarize that for you at the end. But if it asks us to find the sum, and if it's a geometric series, we're going to use that formula there. This is used quite a bit on the AP test as well lately.